Hello and welcome back to this fundamentals of computer networking. This is class 18. In this class we are going to understand ping process. See, however, we covered a little bit about ping process in the previous class. We were understood ICMP will appear when you ping, So in today's class, what happens before ICMP? Okay, what happens before ICMP? We will understand that in detail. Then I will take the next class what happened after ICMP. So let's start. Go to virtual machine. I will go to my setup. This is my VM1. I will go to this computer. I will log in. I will go to VM1. VM1 is already logged in. VM2 login. So in this virtual machine I will open command prompt. In command prompt I will put change the color. I will type ipconfig. See, you see 10.0.10, and you know, right, in last class we were introduced Wireshark. Okay, so I will go to start. I have already installed Wireshark in this computer. I will open Wireshark. So let me choose. It's taking time. Once it is ready, Wireshark, I will choose the Ethernet so that all the data traveling through the Ethernet, it should be captured. So select this Ethernet. Now this is ready to capture. Some DNS query is going on. We can ignore this. But before I go here, I will clear the screen. I will go to VM1. No, I will go to VM2. In that virtual machine, I will check IP address. I will change the color. IP config 10.0.0.20. So I have two computers, or they are virtually connected. Okay, now what I am going to do, I will go to VM1. I will go to Wireshark. I will start the capture again. While capture is going on, I will start pinging to 10.0.0.20. So when you enter this, what happened exactly in the background? First, I will explain you something, then I will come to the Wireshark monitoring. When you start pinging from computer 1 to computer 2, VM1 to VM2, these are the IP address. See, every computer NIC card has a MAC address. I will put MAC address as 00A. Okay, so my trainers used to teach like this. This is one of my old method which I learned and I teach many students. So I am using the same method. So 00B is a MAC address. What is MAC address? We have already discussed about MAC address very well. You can watch our previous classes. You can go and watch that. So you will understand what is MAC address. So every NIC card has a MAC address, right? Let me bring some NIC card so that we can get clear idea. I need to get NIC card. Where I can go and get NIC card? Alone. Desktop. Just a minute. NIC card, yeah, this one. Because I have to explain in detail. That's why I will properly arrange things every clearly so that we can easily understand. See, this computer has an NIC card. That NIC card MAC address is 00A. Just imagine like that. This computer has an NIC card. That MAC address is 00B. Now we gave 10.0.10 IP address, 10.0.20 IP address. So when I went to this PC, okay, VM1, I started ping 10.0.0.10, right? Not 10, sorry, 20. When I start pinging 10.0.20, what happens, immediately ICMP is supposed to come. Let me remove these lines. See, ICMP is supposed to come. Let me take this box as a ICMP protocol. Okay, this box is ICMP protocol. This ICMP is actually, it's a request. Okay, ICMP request came. This request supposed to go where? This request supposed to go to this computer. So what is the source IP address of this request? SIP, SIP means source IP address 10.0.0.10. Okay, source IP address is 10.0.10 and the destination IP address 10.0.DIP. I will put it as DIP. Destination IP is 10.0.0.20. So this request, this packet is originated and going to where? To this. And here we have to understand one more thing. ICMP is originated by IP protocol. Okay, in every computer there is a IP protocol. That protocol will originate the ICMP. No, I'm saying in wrong. It is network layer. I is supposed to say network layer. ICMP is a protocol which originates in network layer. Okay, there are some OSI layers are there. Application layer, session layer, presentation layer, application layer, session layer, presentation layer, transport layer, network layer, data link layer, physical layer. Okay, physical layer, data link layer, network layer, transport layer, presentation layer, session layer, application layer. So these are the 7 layers OSI models. In that layers we take network layer. In network layer, ICMP is a protocol. That protocol originates this ICMP request and trying to send this packet to this computer. Okay, when network layer originates this packet and sending the data to the associate computer, the next is data link layer. Okay, data link layer. What is data link layer will do? Data link layer which is actually present in NIC card. Okay, data link layer, there will be Ethernet will be there. Ethernet. In Ethernet, when this packet is received by that interface Ethernet, that Ethernet has to find out the MAC address of the Ethernet. The NIC card has to hand over this packet to this NIC card. Network layer is communicating to network layer to check the network connectivity. When ICMP is going to play the key role to do all this process, when ICMP generated the request and handovers to NIC card is in data link layer and physical layer. Both layers will be appears here. In this data link layer, Ethernet will be there. This Ethernet, this Ethernet will has to put source and destination MAC address. Okay, so what is the source MAC? SM. I used to say SM, source MAC. Let me put source MAC. What is source MAC? 00A. Okay, 00A is the source MAC address. What is the destination MAC address? DM, destination MAC. What is destination MAC address? 00B. See, I would like to ask one thing. How would this NIC card knows 00B is the destination MAC address? You understand? When you are trying to communicate from VM1 to VM2, you started pinging. When you ping, ICMP request came to reach 10.20. ICMP works in network layer. That network layer, that packet is originated and hand over to the data link layer. Data link layer, which takes the responsibility to put the MAC address of source and destination. When the Ethernet, the data link layer, is to put the destination MAC address, it knows the MAC address of its source, but it doesn't know the destination MAC address. I cannot say simply 00B. See, I know in this picture 00B is the MAC address, we know, but how would this interface will identify the MAC address of destination? See, you are trying to search a person, okay, but his name, you know his name, you don't know his name, but you know his location. It is something like that. You know his location ID, but you don't know his name. You are trying to find, I'll tell you one small example. You are trying to find a person in a college who are doing CSC first year student, B section, and the roll number is 15, something like that. So you know the location, you know the department, you know the section, you know the roll number, but you don't know the person here. Just imagine like this. So what you will do, you go to the department inside the section and the classroom, and you see whose roll number is 15. There you can find the person. Similarly, in this situation, when you doesn't know the MAC address, Ethernet will call one person. That is called ARP, address resolution protocol. ARP. What is ARP? Address resolution protocol. That's a full form. See, the name itself says address resolution. What address resolution? MAC address resolution. ARP resolves MAC address by using IP address. That's the magic of ARP. If you hand over ARP IP address, it will get the MAC address. How? See, when the source Ethernet doesn't know the destination computer's MAC address, this packet will be dropped. Okay, nothing will happen. This will stop. So rather than stopping the whole process, immediately ARP will come into the picture. ARP will generate two packets. There are two packets of ARP. The one is ARP request. ARP request. In ARP request, there will be some information. Source IP address. What is the source IP address of, in this case, 10.0.0.10? What is the destination IP address of this? 10.0.0.20, which means we are handovering IP address to the ARP to find the MAC address. Okay. How ARP knows 10.0.0.20 is the destination IP? Because we gave in a ping command. That will be the destination IP address for ARP to resolve the MAC address. So what is the source MAC address here? 00A as per our architecture diagram. So what is the destination MAC address? We don't know. ARP doesn't know. So ARP doesn't know the MAC address. No, it will put FFF, which means in hexadecimal all F's. If you watch our previous videos, in binary hexadecimal you can identify what is ARP. What is hexadecimal FFF? All ones. Broadcast. So ARP request will go to every computer in the network. Right now we have only 2. Imagine if we have 20 computers, this ARP request will goes to everybody. It will shouting here, boss, if you are 10.20, what is your MAC address? That's the question here. Okay, if you are 10.20, what is your MAC address? That's the question. this ARP will received by every computer in the network, that only one computer is going to respond back. There is one response will come from the computer which is 10.0.0.20, because the computer is exist, it is live and working. So now what happens when this request received by every computer, the only one computer is going to respond back for the ARP request. So this computer is preparing the ARP response as a source IP. What will be the source IP address of ARP response? 10.0.0.20. Destination IP will be back same IP. Why? Because destination IP knows this computer, because the source came from 10.10 only. And what is the source MAC address? 00B. 00B is sending its MAC address. Boss, I am 10.20. This is my MAC address. I am sitting here. This is my MAC address. Okay. Destination MAC address will be 00A. Why 00A? Because ARP request sent its MAC address. That's why it is going unicast. This is broadcast packet. This is unicast packet. I hope you remember broadcast and unicast. If you have not, please go and watch my previous videos. I have explained you there what is broadcast and unicast. So broadcast is one to all, unicast is one to one. That's all. Now once this ARP request came to resolve the MAC address, then this computer knows the MAC address, and this information there where we hold, this information will be filled with the MAC address and packet sent to the destination PC. Okay. When the destination computer receives this information, the whole packet, this is known as packet. Okay. I will take this packet to here. When the packet received by this computer, what happens? It will open one by one cover. See, it will check, the computer will check, oh, this parcel came to me. Okay, destination is me, so my MAC address is 00B. Okay, open this cover. We are opening this cover one by one. Cover opened. Oh, ICMP request. Who is sending? Oh, 10.10 is sending. Okay, super. Now what he has to do? He has to prepare ICMP response for the request. Okay. For this I have to change the response here. Response. So what happens in the response? Source IP will be 20, destination IP will 10. Source IP will be 20, destination IP will be 10. Then again ICMP is going to respond in the network layer. This is hand over to the NICAD. The NICAD will try to send this packet to this NICAD. Again it should know the MAC address, right? It will put the cover again. What is the source MAC address this time? 00B. What is the destination MAC address? Destination MAC address 00A. How would this computer knows the destination MAC address? Because the request came with all the details. That's why it is going to send. This response has generated from 10.20 with the detailing, then sending the response back to the NICAD. Again this packet is received by this NICAD, and it reads the MAC address. It identifies that this is coming from 00B to me, 00A, and it opens and it will see the response message. When you click, when you type this 10.0.20, this is what happened within a millisecond. Okay, within a millisecond this is what happens. I used to ask a question in interviews, and not now, long years back. I will ask a student to can you explain ping process in detail? So students are well understood, they practiced very well, they monitor, so they will identify everything what happens in the background. They explained it very well. sir, when you ping from this PC, ICMP request will generate with source and destination IP. Source that hand over to data link layer in Ethernet will know the MAC address of destination PC. By default it doesn't know the MAC address. ARP request will come, ARP request will broadcast, ARP request will have so and so information, and once ARP received a response from the appropriate PC and it fills the MAC address with the help of ARP response, then ICMP packet request will go. Once ICMP go, then ICMP response come, he will explain everything same in the manner. I will ask one small tricky question. Tell me how much time it takes to explain. Actually it's supposed to happen only within millisecond. Sometimes if I ask, they will get stuck and confused. They will say it takes total 4 minutes, 5 minutes. They will say like that. Okay, so all this happens in within fraction of seconds. That I am going to show you now. See here, this is my Wireshark. I will increase this. Just ignore this DNS, please. Ignore this DNS. I will just search for ARP. I will put filter ARP. How to put filter? This only now. ARP. See, I'm just filtering and showing the packets so that you can easily understand. What is ARP request? I told you, right? I told you Ethernet is originating. It's showing 02 0402. Whose MAC address it is? Check the MAC address. Get MAC. Whose MAC address? 0401. Destination. Who has 10.20? I think I have to expand this. Why it is showing unicast? Just 1 minute. I'm just checking here. It is already came up with a filled MAC address. Let me close this filter. Who has 10.20? 10.28. This is a MAC address. It should go as a broadcast. But it exactly going to the same. Let me close this capture. Close without capture. Saving data. Now ARP space -d. Just ignore this command. I will tell you in another few minutes. So now capture started. I am pinging again from 10.0.0.20, from 10.10 to 10.20. I can see the same capture. I stop. You can see here. This is what I wanted to show. See, this is what broadcast. You understand? In Ethernet, destination address is broadcast. Then now you may ask the question, boss, why the previous was the MAC address? I will show you why it was there. It was in the cache memory. That's why it took that cache memory MAC address. But here source MAC address 01, destination MAC address doesn't know. He doesn't know the MAC address. See, ARP is shouting here, boss, who has 10.0.0.20, tell to 10.10 what is your MAC address. Then when this request originated from 10.10, from this MAC address, it doesn't have the target MAC address. Now it is trying to find out this IP's MAC address. So when the ARP response came, it came with the proper MAC address. See 02 is MAC address. Now what I do immediately, I capture start again. I will ping immediately. I ping immediately. This time you don't see any ARP. See, you don't see any ARP. In last only it's coming. not in the front. Why? See, in last also, see, it loaded with all the details. There is no broadcast here. There is no broadcast. It's loaded. Why? Because once the ARP is resolving the MAC address, no, it puts a cache memory. ARP space -a is a command to see the MAC address table. It's a ARP table which stores the MAC address. So when you ping at the first time, when you ping the first time, it takes first time only, sends the broadcast to find the MAC address. When you ping the second time, it won't send broadcast ARP request. Why? Because it will have the cache memory. If you want to delete the cache, you can use this command, ARP space -d command, to delete the cache. Then again you go to VM1, capture and delete the, stop capture, again start capture data without saving, delete and start pinging again to 10.20. What happens? You see ARP. You understand? When there is no MAC address in the local cache, ARP will go send broadcast, find out the MAC address and get. Then after that, ICMP request reply. See, so if you see here, this is what I was trying to explain. In the network layer, Ethernet layer, ICMP protocol originates packet of ping request, handovers to internet layer, which is IP internet protocol. In that internet protocol will fills the source and destination IP. Then that will handovers to Ethernet. Ethernet will put the source and destination MAC address and handovers to NICAD. NICAD will convert into binaries. Once the binaries will reach to the appropriate computer NICAD, again it converts to frame. The frame converts to packet. Packet will be response. Again response will come. I hope you understood this. What happens when you ping behind the screen? I would like to tell one thing before going to end this class. See, 10.0.0.10. Okay, 00A is a MAC address. In our case, I used to call 00A MAC address. MAC address always binds with a given IP address. The relation between MAC address and IP address. Relation between MAC address and IP address. MAC address and IP address. What is the relation between MAC address and IP address? MAC addresses are always bind with the given IP address. How? 00A in 10 network as 0.0.10. Why I am telling this 0.0.10? Why? Because this is a host ID, this is network ID, this is MAC ID. MAC ID in 10 network as 0.0.10. Similarly, 00B in 10 network as 0.0.20. Okay, that's why when you call 10.0.20, 00B is responding. You understand? So MAC addresses are always bind with the given IP addresses. This is the actual relation between IP address and MAC address. If I tell you in an easy manner, there is a hero called Rajini, there is a robo movie. Rajini in and as robo, which means Rajini is an actor. I think I used to call Rajini sir. Okay, Rajini sir is he's an actor acting in robo as robo, which means he is bind as a robo in robo. Okay, let's take Surya Garu. Surya in and as a Singam, which means hero actor Surya in Singam acting as Singam, which means binding. They are binding with their characters. Similarly, MAC address MAC address binding in 10 network as the given IP address. So binding, just a simple example. If you don't like it, just ignore. Understand the topic. My aim is to make you understand the concept with a few real life example. That's all. Okay. So this is the concept of relation between MAC address and IP address, and this is what the capture happens when you ping in in Wireshark. This is how to capture and see the data. So what we will understand in the next class, we will understand further when there is no computer. Let's ping when there is no computer. Let's see how ARP will resolve IP conflicts. Advantages of ARP, importance of ARP in network. We will understand this in the next class. I think we can stop here.